All right, so I see secant here. I like to think in terms of sines and cosines, so I would rewrite this as 1 over cosine of 3 theta, cross multiply, so cosine of 3 theta is -1. So that happens at the angle pi. So the angle 3 theta is equal to pi plus any 2k pi multiple. So dividing through by 3, 2k pi divided by 3. All right, tangent of theta is like sine over cosine. So when does it equal a +1? When do the sine and cosine of an angle give you the same number so that I get 1? Well, that's going to be here at pi over 4, and that's when they're both positive, and back here at 5 pi over 4 when they're both negative. So pi over 4 plus 2k pi, and then this angle 5 pi over 4 plus 2k pi, and then finishing solving for theta, dividing through by 3. Finishing solving for theta. And these are fine answers. Another way to do this would be to notice that these are pi apart from each other. So you could say pi over 4 plus k pi, then divide through by 3. And this would encapsulate both of these answers. So whichever doesn't matter to me. All right, so here cosine squared cosecant squared equaling -1. That can't happen. You can't have a squared equaling a -1, so no solution. All right, so there's 3 terms here. If you saw x squared plus 3x plus 2, you would know what to do. So I want you to think of the x as cosine. So cosine of theta equaling 0. So plus 2 plus 1. So that gives me cosine of theta equaling -2 and cosine of theta equaling -1. This, you know, is no solution because we're on a unit circle. And this is going to give me pi plus any 2k pi multiple. You'd think this would be similar, only this has got cosecant. So again, I like to think in terms of sines and cosines. So let's write it as the 1 over sine that it is. And I know you've done this before, that if you've got an equation, something with an equal sign, I can multiply to get rid of fractions. So let's multiply both sides by sine of theta. So this gives me 2 plus sine squared theta minus 3 sine theta equals 0. If I took the time to rewrite this, descending order, does this factor similar to what I just had above? I think it does. So it's -2 and -1 this time. So this gives me sine of theta is 2, where there's no solution from that. And sine of theta is 1, so that gives me pi over 2 plus any 2k pi multiple. All right, so let's do a few harder piecewise defined graphs. So you know this is the same thing as saying absolute value of x over x. You recognize it, and you know that's that graph. So here it is up at, oops, I'm sorry, not wrong way. Down here at -1 and up here at 1. And when x equals 0, it's got a filled in point at the y value of 2. So that's the graph. All right, so this has root of -x, so that's a flip over the y-axis, so that's back here, less than 0, so open hole here, and e to the -x, you know what that graph looks like. So from here at the point 1, coming down. All right, so let's make sure we know absolute value of x less than 1. That's the same thing as saying between 1 and -1. So if I'm looking at the graph of x to the 2/3 between 1 and -1, not including the endpoints, I'm picking this up. And it goes up to the y value of 1. So if I was to make a solution graph here, like this, 1 and -1. All right, so now let's graph this, 1 over x squared, and what does this mean? This is the same thing as x's are less than or equal to -1, or x's are bigger than 1. So 1 over x squared is this graph. So what part of that graph am I picking up? Bigger than 1, I'm sorry, bigger than or equal to 1, right? Because it says equal, I've lost the equal sign there. So bigger than or equal to 1, so this part of the graph. Less than or equal to -1, so this part of the graph. So put those pieces together. Their y values are 1, so they connect at this point. So out this way and out that way. So open circle on top of a closed circle is nothing profound. It just means you include the point. All right, so this y equal x squared minus 9 over x minus 3 is the same thing. Let's cancel the x minus 3's, so I'm left with just x plus 3. So I've got the line y equal x plus 3, where x minus 3 cannot equal 0, so that means x cannot equal 3. So if I'm to draw this line where 3 is the y-intercept, right? So there's this 3 is this 3. And I'm drawing a line, slope 1, and then this x doesn't equal 3, that's here, and that's where the hole is, and I know the y value of the hole if I put 3 in for x. So the y value of the hole will be 6. So the y value of the hole, oops, should have made that blue. The y value of that hole there should be the y value of 6. Okay. So that's the first part of the graph. This part says when x does equal 3, put in a y value of 5. So here's 5 a little bit below. There it is. So this passes the vertical line test because it crosses one point all along.